Hi, my name is Jaeseo. I talk about our research about the design and operation of electrochemical CO2 reduction system integrated with the renewable energy system. Electrochemical CO2 reduction system has been studied and attracted the attention as a promising CCU technology to mitigate the CO2 emission. The scheme of the electrochemical CO2 reduction system ECO₂R system can be presented as shown in figure. Using the electricity, CO2 is electrochemically reduced to the various possible chemicals such as CO, formic acid, and ethylene. It can mitigate the CO2 emission with additional profit. But the major question of the electrochemical CO2 reduction system is where to apply this system. To answer this question, integration with the renewable energy system should be proposed. To operate renewable energy system, there is some challenge. Renewable energy system has a property which is spatiotemporal variation in electricity generation. This variation causes the mismatch between generation and demand. ECO₂R system is possible to handle this mismatch of renewable energy system, because it consumes the surplus generation to operate the ECO₂R system. Thus, the renewable energy system is suitable for applying the ECO₂R system. However, there are some challenges by introducing the ECO₂R system. First is the economic feasibility. Trade-off relationship between additional revenue and expense occurs. Consideration of this trade-off relations is required. In addition, to evaluate the economic feasibility of the proposed system, optimal design and operation strategy are also required. Therefore, the research objective is to design of the renewable energy system coupled with electrochemical CO2 reduction system, in short, RE-ECO₂R system, to apply the ECO₂R system. First, the system model is developed. Using the developed model, the optimization model for design the cost optimal system is developed, and using the optimization measure, it is evaluated in terms of the commercial feasibility. Renewable energy coupled with the electrochemical CO2 reduction system, RE-ECO₂R system, is comprised as shown in this figure. PV array system and wind turbines are considered as renewable energy generation units. As energy storage purpose system, two systems are selected. First one is the hydrogen-based energy storage system, such as PEM electrolysis and PEMFC. And the other is the battery energy storage system, BESS. Hydrogen-based energy storage system stores the electricity in forms of hydrogen. Methanol is selected as a product of the RE-ECO₂R system. CO and hydrogen are used to produce methanol. CO is obtained from the ECO₂R system, and hydrogen is obtained from the PEM electrolysis system. To evaluate the economic feasibility of the proposed system, the mathematical models are developed. Major sub-process of the proposed system is the ECO₂R system. The system model is developed using this assumption to implement the performance of the ECO₂R system. Using the experimental data, which is obtained from the co-research group, co-work research group, the ECO₂R system model is developed. The simulation results are compared to the experimental data like this figure. As shown in figure, the results are well matched with the experimental data. So the developed model is well verified. The other sub-process model development and details of the modeling are skipped in this presentation. This table shows the performance of each sub-process which is obtained from the developed mathematical model of sub-process. Like a table, simulation results are well matched with experimental data. It means the developed mathematical model of sub-process is validated. Using this simulation result, the design optimization of the RECO₂R system and then system to evaluate the economic feasibility of the proposed system are conducted. To solve the optimization problem, two-stage stochastic program 2SSP is adopted. In the first stage, X capacity of each sub-process are determined with the expectation value of the second stage. Each scenario is the weather condition, and the scenarios are generated using the sampling method. In the second stage, the operation of each scenario are determined. Assuming non-anticipativity, the sample average approximation and Monte Carlo simulation are adopted. The expectation value of the second stage is calculated to be numerical average of the scenario. So in this research, we adopt the 2SSP and then Monte Carlo simulation and sample average approximation also are used. In this research, the Markov chain Monte Carlo simulation and rigorous technique is adopted to generate the scenario of the 2SSP. This methodology is widely used methodology to predict the weather condition and has been already validated. As shown in figure, the synthetic weather data generated from the developed MCMC simulation and regression technique is shown in this figure. As shown in figure, historical data and the synthetic weather data are well matched. It means the used methodology, MCMC simulation and regression techniques are well validated. So we use this method to generate the scenario of weather conditions. Using 2SSP, the mathematical formulation of design optimization is developed. The objective function of the model is defined as the minimization of cost per power generation output. The main decision variables are capacities of each sub-process and storage tanks, and electricity distribution and chemical production amount. And also some assumptions are adopted to formulate the design optimization problem. The model constraints include the energy balance between electricity generation and consumption and capacity factor of each generation unit considering the weather condition. Left one is used to calculate the wind turbine capacity factor, and right equations are used to calculate the PV array capacity factor. Using the calculated capacity factor, the renewable energy generation unit output are calculated. And operation of each sub-process are also constrained. Energy storage state of the BESS is defined as this equation. And the energy storage state is defined to be between maximum operation bound and minimum operation bound due to its safety issue. Likewise, hydrogen-based energy storage units are bounded by minimum operation bound and maximum operation bound due to its physical size issue and the safety issue. The consumption and generation of each chemical are calculated from the electricity generation and consumption and specific value which is obtained from the simulation result. ECO₂R system and methanosynthesis process operation are also constrained as same as the other sub-process, like this equation and this equation. However, its operation is more strictly limited because the operation of the ECO₂R system and methanol synthesis process can be operated continuously. So the strictly constraints are assumed in this operation of the ECO₂R system and methanol synthesis process. The case study is proposed to design the ECO₂R system in Denver and München. These two sites have different linear energy potential. For two-stage stochastic programming, 30 scenarios are generated using the MCMC technique and MCMC simulation and regression technique. An optimization model is designed as stochastic mixed integer linear programming. And then we use the Groovy solver, and it is conducted in the Pyom library of Python. This figure shows the generated synthetic weather data using the MCMC technique and MCMC simulation and regression technique. Using the generated synthetic weather data and develop the mathematical model of optimization, the optimal capacity of each unit process are determined. In the US, more PV array system is used than wind turbine. This is due to the high solar radiation of the USA. On the other hand, in Germany, wind turbine is the major renewable energy generation unit. This difference of major renewable energy generation unit causes the difference in the optimal capacity of energy storage unit. More BESS is used in Denver because PV does not generate electricity at night. So it causes the dynamic change of the electricity generation. However, renewable energy potential of the USA is much higher than Germany. So it causes more operation of methanol production. And as a result, it causes the increase of additional revenue from the RE-ECO₂R system. So the LCOE of the RE-ECO₂R system in the USA is higher than Germany. This graph shows the optimal operation of RE-ECO₂R system in Denver at scenario 1. As shown in figure, BESS and hydrogen-based energy storage unit are major handled system of generation demand mismatch of linear energy system. This can also be shown in inventory level. Inventory level of hydrogen storage tank is more changing than CO and methanol storage tank. It means hydrogen is used to handle the generation demand mismatch. Operation of the ECO₂R system and methanol synthesis process is determined to be constant, except for the event of generation shortfall. This time step, the inventory level of CO storage tank is after the 1,700 time step, the inventory level of CO storage tank decreased dramatically. In this time step, the renewable energy generation unit output is lower than other time step. So the operation of ECO₂R system is declined, but the operation of the methanol production is not changing. It means the stored CO is consumed. Therefore, the event level of CO storage tank is declined. Operation of the ECO₂R system in Germany is similar to the USA, but the amount of change is smaller than in the US case. This is caused by the major generation unit. In this research, the RE-ECO₂R system is proposed as the application of method of the electrochemical CO2 reduction system. To evaluate the economic feasibility of the proposed system, the system model is developed and design optimization is conducted using the two-stage stochastic programming. And the developed optimization model is applied to two sites which have different renewable energy potential. From the optimal capacity and cost, the RE-CO2R system in the USA has commercial feasibility. Furthermore, the economic feasibility can be improved by considering the CO2 emission mitigation impact of the proposed system and developing the technology itself. This is the end of my presentation, and thank you for attention.